The next class of differential equations is the homogeneous equations. So let's start by defining what we mean by homogeneous equation. Then give some examples, and thereafter we define a homogeneous differential equation. So function f of xy is said to be homogeneous of degree alpha if it has a property that if you multiply t by x and t by y, you get t raised power alpha times f of xy So examples. Determine whether the following functions are homogeneous. Or not. If so, state their degree. Let's start with the obvious one. F of xy given by x power 3 plus y power 3. So solution. To test this, so f of x comma y equals to x power 3 plus y power 3 is a given function. Now we define f of tx, ty, which will be given by tx cubed plus tx ty cubed. This is just the definition of this function. It's t power 3 x power 3 plus t power 3 y power 3. And you can always factorize this to t power 3 into x power 3 plus y power 3. And from definition, x power 3 plus y power 3 is a function f of xy. So which implies that f of t x comma ty is t power 3 f of xy. So f of xy is homogeneous of degree 3, for the power of t is 3. Number 2, f of xy is given by x cubed plus y cubed plus 1. So the first thing, f of xy is x cubed plus y cubed plus 1. This is a given function. So next, now we define f of tx, ty which by definition will be tx power 3 plus ty power 3, then plus 1. This gives t power 3, x power 3, plus t power 3, y power 3, plus 1. But this cannot be written in the form t power 3 of f of xy. So therefore, f of xy given by x power 3 plus y power 3 plus 1 is not homogeneous. Another example, let f of x, y be x squared minus y squared. Now, f of xy is x power 2 minus y power 2 is what is the given function. This follows that f of tx, ty will be tx power 2 minus ty power 2. Opening brackets will be t squared x squared minus t squared y squared. Factorizing will get t squared into x squared minus y squared. But this bracket is the definition of the f of xy itself. So this is t squared f of xy. So this implies that f of tx, ty is t squared f of xy, which implies f of xy is homogeneous of degree 2. Next one, that's 4. F of xy is given by square root x power 8 minus 3x power 2 y power 6. So solution, f of x, y is x power 8 minus 3x squared, y power 6. Square root means raised power half. So this is what is given. So let's define f of tx, ty. So this will be tx power 8 minus 3 tx power 2, and then ty power 6 raised power half, which is the same thing as t power 8 x power 8 minus 3t squared x squared t power 6 y power 6 raised to a half. Now this will be t power 8 x power 8 minus 3 t squared times t power 6 is t power 8 x squared y power 6 raised power half. Now this is the same as t power 8, which is common, x power 8 minus 3x squared y power 6, everything raised power half, which will be t raised power 8 times a half we see t power 8 power half is t power 4. This is x power 8 minus 3x squared. This is y power 6 power half. And this is the definition of the f of xy, so which is t power 4 f of xy. So this is what you're saying, f of xy. So that's f of x t ty is t power 4 of f of xy, so which implies f of xy is homogeneous of degree 4. Another one, f of xy given by 2x plus y. So here, by definition, f of xy is 2x plus y. This is what is given. F of tx ty will be 2 times tx plus ty, which is t into 2x plus y. And this is the same as t f of xy. You can say t power 1. So which means f of tx ty t power 1 f of x comma y. That confirms that f of xy is homogeneous. And lastly, f of xy is given by x cubed sine y over x So by definition, f of xy is x cubed sine of y over x. This is what is given. Now f of tx ty means where there's x replaced by tx, where there's y replaced by ty. Tx power 3 sine of ty over tx, which you simplify will be t power 3 x power 3 sine of, now t and t cancels out, so we still remain x over y, which will be t cubed x cubed sine of y over x. And we see by definition that is what we had as our f of xy. So this is the same as t cubed f of xy. So this follows that f of tx ty is t power 3 f of xy, which means f of xy is homogeneous of degree 3. So now let's define what we mean by a homogeneous differential equation. So a differential equation of the form dy dx equals to f of xy over g of xy is said to be homogeneous if both f of xy and g of xy are homogeneous functions of the same degree. So e.g., if we have dy dx given by three xy plus y squared over 3x squared plus xy is homogeneous since both 3xy plus y squared and 3x squared plus xy are homogeneous functions of degree 2. You can always confirm that for mode 2 of degree 2. So to solve homogeneous differential equations, we make use of the substitution y equals to vx. And now when you differentiate this equation, you get dy dx equals to v plus x dv dx. Then we have a new equation in terms of v and x only, and this is then solved by method of separation of variables. So we'll see how we solve such equations in the next session.